This is section 4.5, day 4, and today we're going to take all the things we've learned about trig functions, writing equations, graphing them, and we're going to apply them to like real-world problems. So we're going to model behavior, which is used in the real world oftentimes when things are kind of following a sine curve, things that increase over time and then decrease and kind of have that predictable pattern. They use sine and cosine curves as kind of a predictor of like when will this happen again. So the first one we're going to just tackle says the table shows the depths in feet of the water at the end of a dock at various times during the morning. So t equals 0 corresponds to midnight. So this is midnight. This would be like 2 in the morning, 4 in the morning, 6 in the morning, 8, 10, and then we get around to noon. So a 12-hour period and different depths of the water at the end of the dock. And then I drew just a quick little graph off to the side. I said, well, the highest point happens at 4 hours in at 11.3, and then I scanned for my lowest value, which was a 0.1, and that happened at 10 hours. So then I've kind of got just this beginning of a cosine or a sine function, kind of that first swooping motion that we've seen a lot as we're graphing these. Then, sorry, I already wrote some things down here, so I'm trying to cover them up. I went through and I said, well, if I'm just trying to write an equation, I'm going to use my same tricks that I was using before, and amplitude is just highest minus lowest divided by 2. So I did my highest value, subtract my lowest, divided by 2, found my A. I did my highest value plus my lowest value, divided by 2, found my D. So those two values should be things that I can find, even if all I'm given is a couple of data points. The period is over 12 hours, so this amount of time every 12 hours is not just because of the amount of data we were given, but if my high happened at 4 hours and my low happened at 10, that's a 6-hour time frame. And so it's going to take another 6 hours for my pattern to repeat itself. So 16 hours in, or at 4 o'clock that afternoon, we should find ourselves back up at a high. So that's kind of the beginnings of what the graph could look like, just based off the couple of data points that I used. So we said, well, if the period is 12 hours, then we're going to do 2 pi divided by 12, which is totally fine. Or you can do 360 divided by 12. You can do that either way. I am suggesting that you probably go to degrees because you're a little more comfortable there, and that's probably what your calculator is set in at the moment. So we were going to put that all together and make an equation to model this data. So again, I apologize because I already started writing before I realized I needed to record this video. So I'm going to put 5.6 in where A is. I'm going to put 5.7 where D is. We had our period figured out. I wrote pi over 6, but when I show you in the calculator, I'm going to make that be 30 degrees. So you can put a 30 degrees there. Excuse me. And then I am writing a cosine function. Cosine tends to be the easier function to write, as I just need to find a high or a low point in my data or on my graph. Finding sine graphs are a little, not harder, but they take a little bit more work because you have to figure out where this middle place is. Since sine is a middle graph, cosine is a high or a low graph. So since I have the highest value and I know that that happened at 4, that's got to be my horizontal shift. So that's why I have a -4 there. That's where the highest value happened, then that is my horizontal shift. So here is one version of the equation that we could write. And although cosine is quote-unquote easier, a little more straightforward, I'm also going to make you write it in sine. So that's what I was doing here when I realized I needed to record this video. 5.6 stays the same, period stays the same, this 5.7 will stay the same. Really the only thing that changes is you flip this to a sine and we have to change our shift. So our shift is supposed to be a middle point, so it could be this one, it could be this one. Typically we like a middle going up, but you can use a middle going down. You just have to have a negative on your function, and that is the one I was starting to write, was this one. So I threw a negative in front, and I was going to use this middle going down value. So I just needed to find the halfway point between 4 and 10. So I can count that out. It's not too bad with a 4 and a 10. Those are fairly easy integers to use. Another way to find the middle is to add up the two numbers and divide by 2. So 14 divided by 2 would be 7. So that would be my shift. So those are my equations. They really should be up here, but I realized I was writing way too big for that. And now this problem actually says find the depths at 0, 9, and 1500. So 0, 9 is going to happen right about here. And so I can already tell my answer is going to have to be somewhere between 3.8 and 0.1. So I already know what the heights are supposed to be, and if it follows this curve, they should be somewhere in here, my answer. So we are going to attempt to plug this in. And it is a little bit tricky if you're not paying attention to where all of your parentheses are. Also do a quick check and make sure that you are in degree mode, because we are actually going to use 30 degrees right here. And the reason that I suggest using degrees over radians is because when you go to type this in, this is going to need to be protected with parentheses, and it needs to be included with all of this stuff, and it's really easy to mess that up. And if you don't have the parentheses the right way, you'll get the question wrong. It'll come out with the wrong answer for you. So make sure you're in degree mode. I'm going to do 5.6 cosine, and like I said, we're going to change this pi over 6 to 30 degrees. That's on our unit circle. That's one of our special angles we've been using. And then we have where we're going to plug something in. This is like our variable. So we're plugging in a 9 right here. 9 minus 4 is 5, so I'm just going to put a 5 there. Watch that you need 2 parentheses to close it. So you got to close the 5 and then close the 30, so don't miss that second one. And then plus 5.7, and you should end up with about 0.85. And that's a good answer because we needed it to be between 3.8 and 0.1, and 0.85 is right in there. So at 0,900, we have a height of 0.85 feet. At 1500, we're going to be plugging in a 15 now. So I'm going to use all the same equation. I'm going to do the same thing. I'm just going to plug in a 15 where the theta is, or that's your variable. So I'm going to do 5.6 cos, still 30. And here's where I'm going to put a 15 minus 4, so that would be 11. Sorry, I think I was pointing to this one earlier. I'm just sticking with this top equation. And then plus 5.7. So we end up with about 10.55 feet. And then just checking to see if that makes sense. So 3 o'clock in the afternoon would end up right about here at 1 hour shy of 1600. And definitely looks like we are almost at the peak of our water height. So 11.3 was the highest we had before. 10.55 makes total sense. We should be, we should be way up at the top there. One more example to go through with you. So this shows the average sales of an outerwear manufacturer. T1 corresponds to January. So January all the way to December. And use a trig function just to model the data. So they just want us to write an equation. So I'm going to go find my highest value. I'll go find my lowest. So my A is highest minus lowest, so 4.3 minus 1.7 divided by 2. And D would be the exact same thing, only add. So the first one's about 6.3, and the other one is 8. So when I start out my equation, I'm going to be 6.3, and then off at the end, I'm going to have a plus 8. And like I said, I like to make kids write these with sine and cosine. We'll do them both ways just so you get plenty of practice. And then you just have to pay attention on the test, which way the question reads or which kind of data you're given. Like if you have high points given in your data, which you will have, then maybe you want to write a cosine one. Cosine's a little bit easier to write, but I would practice both just so you get used to both. So this is going to be our cosine function, and then we'll write the sine function. So we got to figure out our b value, which is related to our period. So period here is, I can look at my high value and my low value, and they are separated by 6 months. And so every time I hit a high to a low and then back to a high again, looks like it's going to be 6 months. So the entire period would then be 12 months. So our b value would then be 2 pi over 12, which is pi over 6. You could also use 360 divided by 12, which is 30. So whichever way you'd like to go, if you go this route, which we are going to do because it's easier to put in our calculator, we'll just make sure we're in degree mode. So I'm going to throw a 30 here. You can put pi over 6 as well. They are interchangeable. And then we have to talk about our shift. So for cosine, where our shift is always for our highest value. You can use your lowest one if you want. Then you would just have to have a negative in the front of your function because you are now an upside down cosine function. This is our highest value. It happened at 12, so that's going to be my shift. Next up, I have a sine value. Now sine is supposed to be a middle point going up, so I'm just going to sketch this real quick. I don't have to. Some people can look at the data and see it, but I just want you to have a visual. So your highest value happens 12 months in at 14.3. Your lowest value happens at 6, and that's at about 1.7. So we need a middle point going up That's nice and convenient. It's already on this curve, so I don't have to keep graphing. So I just need to know the middle between 6 and 12. So I can add those up, get 18, and then just divide by 2. So my shift will be a 9. So really you can write equations whether you're looking at graphs or just looking at data. Start with that high and low, divide by 2. You've got the front and the back end of your formula, so you're about halfway there. Cosine functions will use the highest value, that'll be your shift. And sine functions need a middle place that's headed on the way up.